Gmail. Okay, so now we're finally working. What was going on there? Okay, so video, panel, there I am. Okay, so we have up and running. All right, so now we're going to do this is the final terminal operate, or the final terminal operation. Okay, sure it's done right for streams. Okay, so final terminal operator. So this is static void ex11. Okay, it's 11. And this is called collect. Now, so what is collect? Collect is something called, so collect is something called a mutable reduction. Okay. Now, it's a mutable reduction in that it creates something, it modifies it some way, and then it saves that object. Okay. So it's working on the same object. Okay. So it's more efficient as you are using the same mutable object. Okay, now it's used primarily for taking a stream, and the collect method can create any collection object, can add to any collection object, and then saves that collection object. Okay, so it's used for creating a collection object from a stream, taking each object from the stream, and then saving that collection object with all the items in it. Okay, so there are two different collect methods. Are two overloaded collect methods. Okay, that do the same thing. Now, so here's the first one. The first one is more difficult. So it returns something of type R. All right, and it's called collect, and it takes a supplier object. Now, supplier means it's creating. All right, so if you want to save your stream as a tree set, this supplier will create your tree set. Okay, that's what that does. Now, the second part is the by consumer. This is the method signature. Now, the second thing is it takes is a by consumer. Now, that means it takes an object, it takes two objects and it consumes them. Okay? It takes two objects and it does something to them. Now, what you usually do is that's going to be, let's say, an integer, and this is going to be the tree set onto which you add the integer. Okay? So you have a supplier that creates our tree set. Okay? By consumer, that takes the tree set of integers and an integer. Okay? So the integer to add to the tree set. Now, these method signatures aren't very helpful because they look so complicated. In practice, it's not that difficult. Okay? So it takes a supplier, a by consumer, and a third by consumer. Now, I will show you it. Let's write by consumer or and let's call the combiner. Now, so that's the first type. So I'm going to create a couple of methods. Now, the first thing I'm going to use it is with the string builder. Okay. So, that's right. So just to recap, remember a string builder? SB is equal to, you can't assign a string directly to it. Okay, that doesn't work. You have to go new string builder 1. Okay, that's how you create a string builder. All right, now, so we're going to create a stream. And it's going to be stream string. And I'm going to call it stream is equal to stream dot of. I'm going to do it again. It's whose space afraid space of space Virginia plus space wolf. Okay. Now, so I'm going to write it long form first, this collect method, and then I'm going to write it in short form. Okay, using the double quotation marks. Okay, right. So I am going to create a string builder. Okay, and I'm going to call this word. Look at that. That was quick. Okay, string builder word. Okay, now we're going to create it from the stream. So we're going to create it from this guy. Screen has gone blank. Give a second. No. So we're creating this word from this string. All right. So we're going to put all of these into one string builder object using this collect method. Okay. Now, the reason I'm showing you a string builder first is because apparently that's what they always ask in the exam. All right, but in reality, you're going to be using them to create new collection objects. This tree sets, hash maps, so on and so forth. Okay. Now, so where am I? Wrong examples. All right, so take out all of these. Now, word is equal to stream dot stream dot collect. That's this guy. So we're going to create our string builder object. So I'm going to go here. So first thing is the supplier, and we just create a new string builder. Now that's a blank string builder. Okay, that's a blank string builder. That's the first argument. I'll put the 3 arguments in 3 separate lines. All right, now the second part of it is something called an accumulator. All right, so what happens each time we go along? It takes in, so an accumulator is a by consumer. So it takes in 2 objects and it does something to them. So what does it do? It takes in a, which is going to be the string builder, and B, which is going to be the string. Okay, A, which is going to be the string builder. Now, how does it know that A is a string builder? Because if we look up here, supplier R, okay, by consumer, first argument is an R, and we've said that it's string builder. So whatever that is there, that's what our first argument is. Okay, that's what our first argument is. Now, the second argument is going to be whatever this stream is. This stream is a string. Okay, so A is going to be whatever is created in the first argument. B is going to be the type of whatever stream is. This stream is a stream of strings. So A is a string builder, B is a string. Okay, so this is a consumer, so a by consumer, it takes in 2 objects and it doesn't return anything. Okay, now, so what you can do inside that is I can go A, which is the string builder that's after being created, append A dot okay, make sure this is right. All right, so A, which is a string builder object. How does know a string builder object? Because that's, so whatever is there, that's going to be the first argument here. Okay, B is going to be whatever, this is a stream of strings. So what am I doing? Each time you start off with a blank string builder. So for each string in here, it's going to append it onto the string builder. Do you know what does append do? Append changes the string builder. Remember that? Okay. So for each string, it appends. So it starts off blank. Then it appends who's onto it. Then it appends afraid onto it. Then it appends of onto it. Then it appends Virginia onto it. Then it appends wolf onto it. Okay, so you end up with who's afraid of Virginia Woolf. Now, each time it does that, all right, with this collection object, I'll try and explain this. So it starts off blank. Okay, so word starts off blank. Okay, that's what it starts off as. So it comes along, so this is the guy here. So it's going to append A onto B, so it becomes blank whose. Yes? Does everyone understand that so far? Yeah. Now, as you're going along there, right, it's actually creating two string builder objects. Okay? A temporary one that houses who's afraid. And so as it's going along, it's keeping a running. I'm not explaining this right. I'm going to put in the third argument and try to explain it that way. Okay, so I'm going to put in the third argument here. So it takes in B, C, and it goes B dot append C. Right. Yeah. Hold on a minute here now. Give me a second here. Okay. Right. All right, I'll try and explain that again. All right, so this is the guy we're implementing. Okay, so it returns an object of type R. Okay, so how does it know what R is? It knows R because the first argument is going to be whatever R is. So the first argument is a string builder. All right, so type R is a string builder. Everyone with me so far? Yes? Okay. Now, the next thing, it takes a by consumer, which is going to be R, and something called type T. Now, where does it get type T from? So it knows what R is. So A is going to be a string builder. Yeah? Now, B. So type T is the type that was supplied when we were creating the stream that is what it's based on. Okay? This is a stream of strings. So A is going to be a string builder. B is going to be a string. Okay, so what happened each time is it's going A is a string builder. So if we go A dot append B, what it's doing is it starts off as an empty string builder. Okay, there's the empty string builder it starts off as. And so for each stream, each string in the stream is going to be appended to that string builder object. Okay, so it starts off as a blank one, then it becomes blank who's, then it becomes blank who's afraid, then it becomes blank who's afraid of, then it becomes blank who's afraid of Virginia, then it becomes blank who's afraid of Virginia Woolf. Yes? Now, the one thing I don't fully comprehend is this thing. I realize I haven't done it out myself. I'm not 100% sure what that's doing. All right. Now, B and C are both string builder objects. Right? Because see here, R. How does it know what R is? Whatever that is, that's what R is going to be. These are two string builder objects. Now, what I've written down here, the third argument is for taking two data collections and merging them. I don't really know what it's doing there. So I know that's of no use to you really, but I don't honestly know what that last argument is doing there. I know what the first argument is doing. I know what the second argument is doing. I don't really know what this guy is doing. It's taking two string builder objects. I don't know where it's getting two string builder objects from. Do you see what I'm talking about? I can see this string builder object. That's A. B is each one of the streams, or each one of the strings. It's appending the string onto the string builder object. This one here is two string builder objects. I don't know why. I don't know what that is. I will show you another example with a collection object. Okay. If I create, Who's Afraid of Virginia Woolf? Yeah, so I'll improve it. That's the wrong one. Now I'll probably have to go back and have a look at it again. Who's Afraid of Virginia Woolf? Okay, I don't really know what that last one is doing there. I know what this one is doing, and I know what this one is doing. Okay, so this is a supplier object. Which sets the type R to be a string builder object. Okay, so that means that this guy here, so A here is a string builder, and B is whatever type the stream that whatever type the stream is, which is a string. Okay, now how do I know all that? I know that from up here. See it? By consumer R super T. T is going to be the type of whatever the stream is. All right, right. So I can see that the last one is a by consumer that takes two R's, in this case two string builders. I don't know what two string builders is taking. Right, it's merging two string builders together. So this is merging two string builders. I'm not too sure yet. Not sure. Actually, yeah, that's not a bad idea. No, you can't do peek there because this is all one object. You know what I mean? Collect. It's you can't do a peek inside a method. I could do what I could do is this. I could print this out. Add at a pin B, and I could print out A and see what it's printing out. A is Who's Afraid of Virginia Woolf. Okay, I'm not too sure why that guy is doing that there. Okay, I'm not too sure why that's there. I printed off A before it. So it's blank. Then it goes through the whole lot of them. It pins it as Who's Afraid of Virginia Woolf. So I don't know why it's doing this here. I will come back to that. Okay? I will come back to that. Now, I am going to create a tree set. Okay? Now, this is a tree set of strings. All right? So, it's going to be based on this stream. Okay, so I'll create this stream first. Stream, string, I'll actually base it on this list. Okay, so I'm going to go list, string, and stream 2 is equal to stream, sorry, list 2 is equal to new array list, and I'm not going to change it just so I can do this instead. Arrays.as list, and I'm just going to type in W O L F wolf. Now, so I am going to create a stream from this list. Okay, so tree set, I'm going to call this set 2. Okay, is equal to list2 dot stream. That produces the stream. Now, next thing I'm going to do the collect method. So I'm going to put this on a different line. Now, collect. First thing, so it takes what we're going to create. We're going to create, this takes a consumer object, or supplier object, sorry. So it takes nothing and it returns a new tree set. Now, also, this is a tree set of integers. Okay, how does it know an integer? Oh, sorry, it's a tree set of strings. How does it know a tree set? It's a tree set of strings because list 2 is a list of strings. So when you create a stream from that list, you create a stream of strings. From a stream of strings, we're going to produce a tree set of strings. Okay, so from a stream of strings, we're going to produce a tree set of strings. All right, so new tree set. So the collect method takes a supplier object. Okay, it next takes a buy consumer object. So the buy consumer, what it's going to do. So the first object, so it takes in 2 objects, A and B. Okay, now A is going to be this. So A is a tree set. B is going to be a string. Okay, so A is going to be a tree set of strings. Okay, A is going to be a tree set of strings. B is going to be a string. Okay, and so what are we going to do with, so if A is a tree set, we can go A dot add B. Okay, so we create a tree set, it adds a tree set of strings. Okay, that is a tree set of strings. It's not a tree set of objects. That's a tree set of strings. Okay, that means that A here is going to be a tree set. B, this is based on a stream of strings. Okay, so we're adding a string to each element in the tree set. Now here again we have the last thing. I'm not 100% sure, I don't understand this part. What we're doing then in the very last part then is we're going A and B. Both A and B are both tree sets, and then we have to go A dot add all B. Okay, now again I'm not 100% sure what it's doing there. I understand the first argument, no problem. I understand the second argument, no problem. Okay, it's this one here. I'm not too sure what the hell is happening there. Okay, I'm going to change these, by the way, as well. I'm going to change that to the word T, so I know that that's a tree set. I'm going to change this to the word S, so I know that that's a string. So then I go T add S. Okay, A and B are both tree sets, so that's going to be T1. That's going to be T2. So I go T1 that add all T2. And as I've said, I'm not 100% sure what that's doing there. Okay, because this creates a tree set, and this adds the string to the tree set, and then it assigns the whole tree set to this guy here. All right. So what collections are really for? They're really for creating collection. What collect is for? It's for creating collection objects and adding all of the items of a stream to it. Okay, we've already done it by using a for each. This is just another way of doing it. Okay, this creates your tree set. This adds all your strings to the tree set. As I said, I'm not too sure what this is doing. Okay, so now what does that print out? Now, as it's a tree set, it's not going to print off W, O, or is it? It's going to print them in alphabetical order. Okay, so because remember, tree sets will organize things according to their natural order, or so there has to be a class that implements the comparable interface. The string class does implement the comparable interface. What does it do? It'll order them alphabetically. So I'm going to order this one, set 2, see what it looks like. It prints off F, L, O, W. Okay, why? Because it's a tree set. So what does this do? This creates a tree set which orders our strings in alphabetical order. Okay, first argument of collect. First argument creates a tree set. This argument here, that means that T is a tree set and S is whatever the type of stream it is. It's a stream of strings. Okay, list2.stream creates a stream of strings. Okay, and then we call collect on it. And what does collect do? It creates a tree set, it adds numbers to our tree set. As I said, I don't know what that guy's doing there. I will have to look it up. Now you can write a shortened version of this. Now I'm leading up to a lot simpler method than this. There's a lot simpler method than this. All right, I have to show you the complicated method first before I show you the shortened one. Now you can use the semicolon operators here, double semicolon operators. So I'm going to redefine this guy. So I go set 2 is equal to list 2 dot stream. Okay, dot collect. I have to make sure this is right. Instead of going new tree set, we can go tree set double colon new. That'll be the first argument. Instead of adding to a tree set, we can go tree set double colon add. And then we go tree set double colon add all. Now, that guy is doing the exact same thing as that guy. Okay, that's creating a new tree set. Okay, so it knows that tree set.add. It knows that the first item it takes in has to be a tree set because this guy here is creating a tree set, so you can omit the T. It knows that S is a string because it's based on a list. A stream of strings was created from this list of strings. So you can eliminate both T and S. So it knows that T is a tree set. It knows that S is a string. Okay, it knows that T is a tree set of strings. Okay, it knows that S is a string. So what's the logical thing to do? So that means if I go tree set.add, it knows that the only thing that can call .add is T, and the only thing that can be added to it is S. So you can omit both T and S and put in tree set.add. Now tree set.add all is doing this thing again. You have two tree sets and it's adding them together. Now I'm not too sure where it's getting the two tree sets from. Okay, so that is the exact same as that. Now there's a lot simpler method. So the other type of collect method. All right, other type of collect method. Now you've got this. This looks like bullshit. Okay. Right. A collector is basically all of this. Okay. A collector is all of this. Okay. That's what a collector is. A collector is all of that. So anything that produces a tree set or anything that produces a list and adds to that list, you can put in for this collect method. Okay. Now, what I'm going to do is I am going to create a stream. So this is all going to be one line. Stream dot generate. So I'm going to be producing 5 random numbers. So I'm going to go int math.random multiply by 100. Takes supplier, so takes nothing. That's what it returns. Bollocks. Okay, and I'm going to limit it to 5 numbers. going to have a peek at them. So I'll put this all on different lines. So I'm going to produce 5 random numbers. I'm going to have a look at them, see what they look out. And it's only at this point then that I'm going to save them to a set. Okay, so dot. So I go collect. Now, this collect object takes something that's a lot smaller. Okay, now if I want to save all of these numbers as a set, it's very simple. There's a simple method to do it. It's simple as this. It's going to be collectors collect collectors dot to set. Bollocks. No. Why isn't it allowing me to do that? Set integer. Okay, sorry about this. No, why is this doing this? Sorry about this. String integer string 2 is equal to stream dot take a break for 2 minutes. I need to recap shit in. Okay. All right, so sorry about that. I unfreeze it. All right, so I'm going to comment out this guy. All right, so I created a set of integers and I called it set 3. Okay, now I'm going to generate uh, random numbers. They're all ints. I'm going to limit them to 5. Okay, now here we have collect. Now all you have to put in here is you have to create a set from something called a collector. Okay, so now why does it have to be a set? Because we assigned this to be a set here. All right, so you want to create a set, very simple. So all you have to do is int math.random100 limit 5 collect collectors to set. That does all that does the exact same as that. Okay, so I'll say that again. That does the exact same as that, except in much shortened form. All right, so a collect, it takes a collector object. Okay, collect takes a collector objects. Now collector has got the two main methods of the collector class that we're going to be using is, well, one of them is called toSet. Okay, that's for creating sets. Now if you want to create collections of particular types, you can also do this. So I'm going to rewrite this guy. Okay, except this is going to be a tree set. And this is going to be a tree set of integers. I'm going to set 4. And it's going to be all of this. Same thing again. Except at the end, I'm going to go collect. And so it takes a collector objects. Okay? Collectors dot. Now, to collection. A collection is any list, any set, or any Q. Okay, so toCollection. Now, toCollection takes a supplier object. Now, it's a supplier object that we want to use to create a tree set. Okay, so I'm going to put in here. So I'm going to put in a supplier object. So supplier object takes nothing, but it returns a new tree set. All right, I'm missing. All right, now what that does is generates 5 numbers, and then collect takes a collector object. Okay, takes a collector object, and one of the methods of the collector class is called toCollection. What does it take? It takes a supplier object that will create a tree set. So this will create a tree set that will be populated by the 5 numbers that are created here. All right. So this will create a tree set that will be populated by the 5 numbers. So what does this do? This creates a tree set which will be populated by the 5 random numbers. Okay, and assigns this tree set to the variable set4. Okay, now I'll peek at it. So I want to see what it looks like. Put that in the next line. So I'm going to see what the numbers look like. I'm going to peek at it. So I'm going to generate them. It's going to limit it to 5. It's going to peek. This creates a tree set and adds all the elements to the tree set. That's what that does. Okay, so this creates a tree set of integers and adds each of the above numbers of the stream to the tree set. Okay, and this tree set is then assigned to set4. And to prove that it is assigned to us, so now it produces the numbers at random: 50, 39, 18, 84, 0. But a tree set organizes them in ascending order. So it goes 0, 18, 39, 50, 84. Okay, so here you can see you can create any collection type on the fly. Now, not hash maps. Okay, you can't really create hash maps from streams. You can create values of a hash map. You can create keys of a hash map, right? But you'd probably be using a for each. All right, so if you want to create a hash map, you'll probably have to use a for each. So we can see here, this generates our random numbers. This limits it to 5. We have a look at them. And this here creates a new tree set of integers and adds each one of the numbers generated here to this new tree set. Okay? Sorry? This is method chaining. Okay? It's a method calling a method. This is method chaining. Okay? Streams are all about method chaining. Okay? This is method chaining. Stream is calling generate, which calls limit, which calls peak, which calls collect. Stream.generate creates stream. This creates stream A. Okay. Now limit 5 creates stream B and closes stream A. Peak creates stream C and closes stream B. Now this is a terminal operator. This is a terminal operator that's running on C. Okay, it's a terminal operating that's running on C, which takes those 5 numbers and that string and adds them each to a new tree set that's been created. Okay, now you can make any type of collection object. All right, I can make tree sets. Let's say I want to make something else. Let's say I want to do a linked hash set. Remember those guys? So if I want to do a linked hash set, I would go linked hash set of integers, and I'm going to call it LHS. Now, before I do that, set 4. Right. So you can go new tree set, or you can also do tree set double colon new. Okay. So that does the exact same thing as that. Okay, that's a shortened format of it. Okay, using the double. So this is the same. Does the exact same as the above. Okay. So previously what we had to do was we created a tree set or created a list, and we added items to the list inside of for each. This is another way of doing it. Okay. It's debatable whether this is better than the other way. The other way was we created our stream, we did our limits, and then we had a for each at the end, and we added each element to the list or to the tree set. Now we can also create array lists. So I'll create an array list. So let's say list integer my list. And I go array list new all right, or I could do a linked hash set. Linked hash set integer LHS int is equal to all of this. Hold on a minute, that's string. So I can do all of this again. So linked hash set, I can go linked hash set new. Okay, need to import that. So this collect method allows you to quickly create whatever type of collection you want. Or an alternative, as I've already said, you could do something like this. You could go list integer numbers is equal to new array list, and you could do all of this. You go stream.generate.limit.peak dot for each and add the numbers to the array list. You would go numbers add. That's also valid. Okay. You can use these. You can use the collect method to save them in an array, or you can just create, or say to save them to a list, a hash map, or sorry, a tree set, a hash set, a linked list, a array list, a array deck. Okay. You can add them to any one you want, so you can use this method. This is an alternative method. All right. Now it's debatable. I actually think that's easier than those guys, but those guys are examinable. Okay. Now I will come back to these because I need to find out what this third argument is doing in this. I still don't know what it's doing. Okay. Now that is all the terminal operators. All right. That is all the terminal operators. And as I said, we should be finished streams as a whole next week. And then when I'm finished, what I'm going to do is I'll do out a Word document that lists off all of the methods you need to know of streams. So you need to know the terminal ones, and what we're going to be doing next is the intermediate operations. Okay? Because there's a lot. There's a lot there. All right? There's an awful lot there. To what level do you need to know it? I don't know. Sorry, kid. Um, no, collect is a method. It's something called a collector. Okay. Now, collector is a interface. Okay. It's an interface. Now, it's not a yeah. It's an interface, but it's not a functional interface because, for instance, it's got to collection and it's an interface, okay, and it has these methods of it. All right. Yeah, but I will come back to these. I have to come back to them. Okay. So the next thing we're going to do is, so that's section 4.4. So the next section, so I'll stop the video. So I'll stop that.